Okay, so a little bit about the Jurassic Coast Trust. So the Jurassic Coast Trust is an independent charity. We coordinate and facilitate the conservation of the World Heritage Site. We don't own any of it, of course, and it's a massive partnership effort that goes into looking after it. And it is the World Heritage status of the coast that we are really charged with looking after and providing advice and knowledge about. And it is a really remarkable thing. UNESCO, who are the people who oversee World Heritage Sites globally, use this kind of definition to understand what they mean by World Heritage. So there are places where the significance is so exceptional that it transcends national boundaries, and they are valuable and important and relevant to all people, not just now, but in the future as well. And in fact, it's not just about places being uplifted as very important or special. It is a sort of political project, if you like, because World Heritage is a tool that UNESCO use to help them deliver their wider mission of building peaceful relationships between nations and promoting sustainability. So in that way, you can see language like exceptional and transcends national boundaries as a way of elevating things to be relevant and meaningful to everybody and break down those barriers and break down those boundaries that we set up between cultures. So in a sense, the Jurassic Coast as a World Heritage Site belongs to people all around the world, and so do all other World Heritage Sites in other countries belong to us in this country too. So it's quite a big idea, but it's not everything about the coast that fits into that definition, because you have to have particular qualities and prove that they have that level of exceptionality. And for us, it's all about our geodiversity, our rocks, fossils, and landforms, and all of the processes that form and shape them as well. So that includes rockfalls and landslides. So the World Heritage Site here, the Jurassic Coast, the Dorset and East Devon Coast World Heritage Site, is about 95 miles long, runs from Exmouth in East Devon all the way through to just around the corner from Old Harry Rocks in Studland. It doesn't include the town frontages, but it does include the beautiful and wonderful open coast that's wild and eroding and tumbling into the sea. And to really understand that geodiversity, you actually don't have to look very hard. You can just look at the colours of the rocks. So if you look at the coast of East Devon, you get these gorgeous red rocks. A few miles away, you've got coastline that looks completely different. The grey rocks in West Dorset around Charmouth and Lyme. Again, a few miles down the road, you've got the golden cliffs of West Bay and Hyde Beach, then the creamy coloured cliffs of Portland, and then of course the white cliffs of the Chalk, which crops up in different places along the World Heritage Site. So just within the range of colours, you can see there's a lot going on. There's a lot of diversity in our geology, lots of different rock types. And we can look at that even further by looking at the fossils that are inside those rocks and find that there's a massive diversity of those as well, from reptiles that lived on land to fish swimming in the sea, and even insects as well that were buzzing around in swamps and forests and all sorts of other kinds of things. You piece all the evidence together and you look at the inside the rocks at the clues and the fossils, and you piece it all together and you can come to understand that actually those different sorts of rocks all formed in very different environments and under very different processes. So some formed in deserts, some formed at the bottom of the sea. Sometimes those seas were shallow, sometimes those seas were deep and full of all sorts of creatures and beasties. Sometimes it was the land, so you had swamps or forests or lagoons or great big river systems flowing across the land as well. So through time, across millions of years, in fact across 185 millions of years, and the Triassic, Jurassic and Cretaceous periods of geological time, the variations in Earth's climate and the environments here all gave rise to a lot of different rocks being laid down. Now, what has that got to do with landslides? Well, of course, all of these different rocks that we have crammed into 95 miles of coast all behave differently when they are interacting with the dynamic processes that affect the coast. So some are harder, some are softer, and more generally, you know, the softer rocks will erode or collapse more rapidly than the harder rocks. And that's just what we see. So we have places like Ladram Bay, where the harder sandstone has left behind these spectacular stacks of rock. And this is an iconic feature in East Devon and part of the area of outstanding natural beauty there, and recognised as a part of the fantastic landscape. But they exist because of the sandstone rock that the cliffs there are made of, sandstone that formed in the desert millions of years ago. And then you can go somewhere like Lulworth Cove, and we can see that it's not just about the rock types, but about how those different rocks interact next to each other within the landscape. So here at Lulworth, you have hard rocks facing the sea, and then behind them are lots of softer rocks. And once the sea is punched through those hard rocks, the soft rocks behind have been eroded out, scooped out by the sea to make that beautiful horseshoe-shaped cove. And all the rocks in between are going to be behaving differently and slumping or sliding or collapsing or falling in their own particular ways. And then you've got things like Durdle Door, of course, probably the most iconic feature on the whole of the World Heritage Site. Again, all formed in one way or another by rockfalls and landslides. So much so that apart from the fantastic rock record through time and all the fossils that are stuffed inside those layers of rock, the coast is also recognised as an outdoor laboratory for the study of coastal geomorphology. That is, the landforms and the landscape and the processes that shape them today, the more recent stuff, the stuff that's live now, happening now in front of us. That is part of that significance that UNESCO has recognised. So for us, it's not just the rocks and fossils, it's also the landforms and the processes that shape them. So the rockfalls and the landslide, they are part of our World Heritage status. And really, these kinds of processes are the coastline itself forming. In fact, the first place a landslide or rockfall was described in a scientific way was right here on the Jurassic Coast in 1839, when the Bindon landslide occurred, and that was just the other side of, well, just west, I should say, of Lyme Regis. And it's the dynamism of this place. So I put this quote on screen. It's the fact that the energy systems that are in the atmosphere and the sea and on land are all meeting and interacting. It's the only place on Earth that happens, and it makes this incredibly dynamic place, uniquely dynamic place, really. And because they're all about coastal change, rockfalls and landslides driving coastal change, we can think of them as a force for change, and the coastline itself as a product of change itself. And sometimes that change is rather unwelcome. Sometimes it can be scary. Sometimes it can be actually really positive and good. And quite often it's all of those things at once. And so it can be quite difficult to unpick exactly how to think about, how to approach these kinds of events. So I'll go through a few examples then of the kinds of landslide events that we have seen on the coast in the last few years. So this was one of the big ones that occurred not long after I started working at the Jurassic Coast, actually. This is at Dunscombe Cliff between Branscombe and Sidmouth. And this was an enormous great collapse of the sandstone that sits right at the top of the cliff there. And you can see it spilled right out into the sea and cut across the beach. And the pile of rubble, the bigger blocks that came down in that landslip, are still there today. Now, it was very dramatic. It didn't affect anything on top of the cliff, apart from the coast path that had to be moved a little bit and some agricultural land. So nothing as such was threatened. But what it did do, the impact it had, was ever since it has altered the way the sediment, the beach material down below, has been able to move sideways up and down the coast, because effectively it's created this barrier. So the beach material finds it difficult now to migrate through where that landslide has occurred. And I've heard coastal technical engineers talk about the fact that the shingle can get around what's left of the Bindon landslide, but it can't get back. And that might be partly responsible for why the beaches around Sidmouth have been seen to be depleted over time, you see. So even though landslides happen, they can affect other processes along the coast laterally as well, even though they happen in particular spots. So here's another example from 2013. This is in Manowar Cove, just next to Durdle Door. And this was a great big enormous slip in the chalk. And the reason this occurred is very different to the one at Dunscombe that I just showed you, where it was sandstone at the top of the cliff collapsing down. This is in the chalk, and it partly happened because the chalk layers here, rather than being left to be nice and horizontal as they were deposited, they've been tilted up and lifted to be almost vertical by tectonic processes from about 25 million years ago. And because they're nearly vertical, those natural planes of weaknesses in between the layers allow rockfalls to happen. And this was a really big one, absolutely enormous. It took a big bite out of the coast path. The coast path had to be moved. Happened early in the morning, thankfully. Nobody was hurt. And again, it just kind of, it meant the coast path had to be moved. But other than that, it didn't really have any negative effects. And by the way, that entire pile of rubble there that's, you know, going up 100 feet on the cliff almost, that's all gone. That's all been washed away by the sea now. If you go back there, it's just bare cliff face again. The next one. So this one is, this was one of my favorites that's ever happened. This was really interesting for me. So this is near Bowley's Cove, near Weymouth. This is very familiar to me. This is very near where I grew up in Sutton Point. So I used to come down to this piece of cliff as a kid. And you can see that the ground here is being torn apart in what became referred to as the crack. And this is what we call a rotational slip. Catherine will be on to explain how these things occur in more detail later on. But essentially, you've got porous limestone sat on top of impermeable clay, and the clay becomes slippery, and the whole piece of limestone above starts to kind of slip forwards from the bottom, and the top kind of falls down and sinks down and tilts back as it does. So they tend to be quite slow rather than sudden movements, and that's why you get this tearing effect, and you get to see it in progress, if you like. And this really captured people's imaginations. And I swear it must have been to do with the fact that it was just running through the cropped grass that was part of the coast path here. Now, again, there was no houses at threat, nobody was hurt. The coast path was easy to just move inland, but the fact that you could see this chasm opening up, tearing the grass apart, tearing the path apart, really, really caught people's imaginations. It made national news, and nothing was spilling onto the beach. There wasn't a great big slip to show you. It was really just this crack. And I think I went on to, I think it was You and Yours on Radio 4 to talk about this. It was very, very strange. And I've thought about it often, why this caught people's imagination. And the only thing I've been able to come down on is that it was in this kind of turf, basically. It was kind of like a bowling green, you know. I think if it had happened on another part of the coast in long grass where people couldn't see it, nobody would have noticed it happening at all, and it wouldn't have come up on anybody's radar. So really fascinating kind of reaction to these things. And that's what it looks like today. So if you went down there now, it would probably, you wouldn't have suspected that that was ever like that before, a few years ago, a big crack. And then, of course, a couple of years ago, we had this enormous landslide between Ypres and Seatown, largest landslide of this kind on this piece of the coast in living memory. And then it moved again this year as well. Both times it made national news. Both times James Loveridge went out there with his fantastic drone to take these amazing photographs that he very kindly lets me use, which is fantastic. Interestingly, this last slip, if you can see the darker patch at the back of the cliff, actually it wasn't new material that slipped. It was the existing material that had been destabilized that kind of shifted again and moved down onto the beach. But again, like the Dunscombe cliff, this has altered the way the beach is going to behave for the long term. So whilst the mud and the silt and the clay will get washed away by the sea, there are great big boulders in there that are going to sit there for years and years to come, decades to come, and they're going to alter the way the beach behaves. It'll be very, very interesting to see how that evolves. Of course, more might collapse as well behind this. Now that this is destabilized and this landslide is kind of active, more stuff might come down, and that's being monitored. A lot of people didn't notice, though, that another one happened at Charmouth. Perhaps you did, perhaps you didn't. But it didn't make national news, that's for sure, like the Seatown one did. But it was pretty big. And the problem at Charmouth, when one of these happens, is that there are often people the other side walking up the beach, and they can get easily cut off. So they've walked up the beach and they turn around, find there's a rockfall happen behind them, and they've got to clamber over it to get back. And that has happened before. Often the sea comes in and meets the toe of the landslip, and so they've got to climb over the top. So there's a hazard there in trying to get people back along the beach safely. But apart from the big rockfalls and landslide events that happen, we get smaller ones that happen more regularly. So here down at Sidmouth, at Eastcliff, This looks very dramatic and impressive, but in fact it is a relatively small rockfall, so not very big in the grand scheme of things, and yet it creates this rather spectacular cloud of dust that everybody on the seafront can see and can take photographs. And you can bet your bottom dollar that everybody on the seafront there is reacting differently to that. Some people are taking out their phones and going, wow, and some people are barely noticing it or not, or just ignoring it, or maybe thinking it's some kind of explosion happening. Other people are thinking, I'm never coming back here again. So it's a really fascinating one, that one. We get these kinds of mud flows. So again, these are a type of erosion. They don't tend to be very dramatic. They happen every year where you get the muddy cliffs, particularly at Charmouth. And almost every year you get people clambering on these unsuspectingly, getting stuck and being rescued by the Coast Guard. Now, on their own, they don't really pose a danger to life like the big rockfalls do, but it can be scary if you get stuck in them. And of course, if you get stuck in them and you're trapped and the tide's coming in, that can be quite dangerous. So it's important that the Coast Guard go out to rescue people. So there's certainly a hazard, but not one that perhaps people might recognize as often as these kinds of things. So this is the one that's often in the papers, the newspapers, the online, on the telly. People might be more familiar with the rockfalls in these locations than anywhere else along the coast. Now, the cliffs between West Bay and Hythe Beach for a long time were barely active. They very occasionally there'd be a rockfall, but not very often. But in the last 10 years, they seem to have become very, very active for one reason or another. And there's been a rockfall every year. Sometimes there've been 2 a year. And they've created a lot of attention and an awful lot of concern as well, because they're very, very sudden. And when it comes to managing these kinds of things, because they come under the sort of bracket of coastal change, if you like, we can think about them in that context and think about, well, what are the ways in which we deal with coastal change? And there are 3 ways, really, that we come at coastal change in general. So first of all, it's how do we protect communities when they need protecting from it? And that happens through the planning system and coastal defences and things like that. We can come at it from the point of view of conserving the natural environment, because these natural processes often are what create the habitats and obviously the geological exposures, and often protecting the natural environment on the coast can equate to allowing the coast to evolve naturally through these processes. So although rockfalls and landslides are often perceived to be destructive, for nature, they're very good. And then, of course, there is the management of these things as hazards. And as you can see with the photograph on the right-hand side there, it is quite a challenge. And really managing them as hazards, I'll just dwell on that point a little bit. It tends to be about the preparedness that we have. Are we ready for when these hazards occur? And how do we respond to them when they do happen? So now I'm going to show you this video. You may have seen it. There's no sound, but this was from this year. And this came through via the Dorset Council. Somebody was shared with one of the coastal rangers, and my jaw just hit the floor when I saw this video. Now, I have seen videos of these happen before from a camera that the Environment Agency have on the pier at West Bay. It captures these, but I've never seen one this close up, and also one that shows people in the frame reacting to it as it's happening. It's absolutely extraordinary. It's quite scary. Thankfully, nobody was hurt, but it's such a gift for us to be able to use this to demonstrate to people who might not be aware that these hazards exist and the way that they occur, to be able to illustrate the reality of what happens. I mean, this is over in literally seconds. And if you arrived 5 minutes after this happened or 5 minutes before, you would never imagine that this was about to happen or had happened. Absolutely amazing to be able to have that footage. And that's one of the big problems when it comes to dealing with these things as hazards, not just reacting to them when they happen, but also getting ready and trying to inform people about it. It's the perceptions that people come to the coast with. So often people will come and see things like this, big piles of rock on the beach, and they will not connect it to a rockfall event. They will not interpret it as a natural feature sometimes. I have spoken to people on the beach who have assumed that these piles of rocks have been put there deliberately by the council, perhaps, Perhaps that's because they're used to seeing rock armor in other places and they assume it's the same. Some people don't even don't even think about it. They just think it's a feature of the cliff and they don't think about how it got there or what might be involved. Part of that, I think, is to do with this lack of appreciation, perhaps, that the coastline is a wild place. They come to the Dorset coast maybe for a lovely seaside holiday. They think of it as a lovely, safe place to come. They don't equate it to the kind of wilderness places like the Cairngorms or Dartmoor, where people go there and they get into trouble every year. But there's a more of an appreciation, I think, that those are very dangerous wild places if you're not prepared. Whereas a beautiful English coastline, that's a safe, lovely place to go on holiday, isn't it? And there's also a good deal of it'll never happen to me attitude. And whilst a lot of people will scoff at that, I have to ask myself, really, isn't that unreasonable to have that opinion? Because people have been killed by rockfall. There's no doubt. There was, tragically, somebody lost their life in a rockfall on this stretch of coast in 2012. But actually, people being caught and killed by rockfalls is generally very rare. And your chances of being caught in a rockfall are very, very low. So is it unreasonable for people to go out and explore the beach, explore the coast, or even sit under the beach? We'd rather they didn't, but sit under the cliffs and think, well, it's unlikely to happen to me, so I'm all right, mate. I don't know. It's difficult to answer that one, because the problem is, if they are unlucky and they are caught in a rockfall, then it's a very, very high chance that they will be seriously injured or unfortunately will lose their lives. So it's a very difficult issue to approach. But we can think about some of the responses we might have, and actually how those responses themselves can have their own consequences. So this sign was put up by the National Trust at Hyde Beach after the person was killed in 2012, and you would think that is a perfectly reasonable response to have, a sensible response to have, a very clear, decent warning sign about what the hazard is. No problem with that whatsoever. However, a year later, when this rockfall happened at Man o' War Cove, this is the same one as I showed you earlier, one of the conversations reported to me, one of the rangers down there on the Lulworth estate reported to me a conversation with a person who talked to them about this landslide and said to them, if it was dangerous, they would put a sign up like at Burton Bradstock, Hyde Beach, which is so revealing, I think, about the kinds of attitudes that we may not realize people are having and the effects that our own response to try and promote the hazards and make people aware that can have. Because, of course, that person thinking they would have put the sign up, who are they? Okay, there's a perception that we are all working together collaboratively and consistently to manage these hazards. And, of course, we do try to do that as best we can. But ultimately, all the hazards are unique. So they need a unique response in different locations. It's difficult to be consistent and still reflect the reality of what the hazards might be. And of course, landowners have their own ways of dealing with them as well. So, it's very, very difficult nut to crack. Are the signs the right signs? Do we have enough? Are there too many? Is it clutter? Are people then going sign blind, as it's called? Are we doing enough to promote the hazards in advance of people visiting the coast? I mean, talks like this tonight, this is a part of that overall work that we are doing collectively with all our other stakeholders and partners, the council, the rangers, landowners, everybody, to try and promote these things. But before I hand over to Kath, just to touch on some of the good things we get out of rockfalls and landslides, because it's not all bad stuff. So this example here, this view that we are looking at, like I said before, this has all been created. This beautiful scene has all been created by the coast changing over time, collapsing into the sea through rockfalls and landslides. From that, we get the World Heritage status as the rocks and fossils are exposed and the natural processes are allowed to continue. This whole view, this whole coastline is designated at European level for wildlife. So it's protected at that level too. And it's part of a national landscape for its natural beauty. And beyond all that, it's also a really important economic asset because it brings people to the area. It makes them want to live here and stay here and connect to it. And it's what we love about the coast, isn't it? So there are so many positive things we get from rockfalls and landslides continuing. And let's not forget that these kinds of iconic features that we love to visit, love to be around, love to think about being part of, these formed from rockfalls and landslides. Now here at Ladram Bay, if you look at postcards from 100 years ago, some of these stacks were connected to the land in wonderful rock arches. There were rockfalls, and those rock arches eventually collapsed. So they no longer exist here anymore. We've just got the stacks left behind. One day, there will be a rockfall here, and Durdle Door will not be Durdle Door anymore. And how are we going to feel about that when that happens? Somebody said to me once that Durdle Door is like a shooting star, but on a really, really long time scale. It didn't exist once upon a time, and there will be a time in the future when, again, it no longer exists. But we are the lucky ones that are here to see it and enjoy it. So what other new amazing things are rockfalls and landslides going to create for us to marvel at on this coastline in the future? So whilst we have to respect the coastline as a wild place where there are active dynamic processes that continue and that create hazards and issues for us to manage and respond to, and again, respect, it's also worth just considering that we can also make room to celebrate these processes as well and remember all the great stuff that we get from them too. Right, on that note, I will attempt the technical wizardry of handing over to Kath. Now, this is the exciting bit. Right, stop sharing. Okay, Kath, hope you are ready. Is that working for you, Kath? Are you unmuted?
Yes.
Hey, well done.
I couldn't turn my camera on there, so I was having a little panic, but it's okay. I'm here.
I'll mute myself.
Brilliant. Thank you very much. That was really interesting. I'm glad somebody else has got a favourite landslide as well, like me. So I'm going to talk a little bit about the British Geological Survey's work and a little bit about landslides themselves. So I will just share my screen. So yes, I'm Kath Pennington. I'm an engineering geologist and landslide specialist at the British Geological Survey. And thank you very much to Sam for inviting me to come and talk today about some of the work that we're doing. So I thought I'd start with who are the British Geological Survey and what sort of things do we do. So we are the oldest geological survey in the world. We are a world-leading impartial scientific institute. We're a public sector organisation working within the UK and also internationally. And our focus is public good science and research to understand earth and environmental processes. And we're the premier provider of objective and authoritative geoscientific data, information and knowledge. And we aim to help society use natural resources responsibly, manage environmental change and also be resilient to environmental hazards like landslides. We work at all scales in terms of spatial scales, from local sites all the way up to national scale and then global scale. And we also work in very long time scales, but also all the way into real-time data. We've got 5 main offices, which you can see on this map here. We've got Edinburgh, Cardiff, we've got a small site at the Natural History Museum in London, Wallingford, and then HQ up in Nottingham. So this, don't worry about the details of this rather frightening table, but I just wanted to include this because it shows kind of where we sit within the public sector and the kinds of organisations that we're working with, like the Met Office and the Environment Agency, SEPA, Natural Resources Wales, etc., across all the different nations of the UK, but also with local authorities, all local authorities, as well as the public and consultants, coastal managers and local resilience forums, for example. In terms of how we're structured, in terms of where the landslides team sits, we are within the multi-hazards and resilience science challenge area within which our engineering geology team is, and the Landslides team sits in there. So these are the core people in the current team. You can see that we're mostly made from engineering geologists and geohazard specialists, but we have the added advantage of being able to tap into nearly every kind of geological and environmental expertise within the organisation, but also with our partners. So we do a lot of work collaboratively with others. Before we get started, I thought I'd just take a moment to define actually what a landslide is and how we differentiate the different types. So a landslide is essentially a mass movement of material like rock, earth or debris down a slope. It's when the force of gravity acting on the slope exceeds the resisting forces of the slope and it fails and you get a landslide. These can happen really very quickly, as you've seen on some of the videos Sam showed. They can happen quite slowly, or they can happen episodically over very, very long time periods. And they occur in pretty much all geological and geomorphological situations. So we've divided up, I say we, the scientific community have divided up landslides according to different types, and I will come back to these and talk about them all, but this is an internationally recognised set of definitions. So what actually causes a landslide to happen? So we've got two different types of factors here. So we've got what preconditions a slope to be likely to fail, and then what kind of tips it over the edge. So the kinds of things that precondition a slope are what the geology is. So what's the material? Has it got any structure in it, like faults and fractures? How steep is the slope that it's sat on, and what's happened to it in the past? So the glacial history in the UK has had quite a large impact on the geology in terms of its strength for much of the country. The kinds of things that can trigger a landslide happening are heavy rainfall or prolonged periods of rainfall, changes in the water table, changes to the material strength through any kind of weathering, like erosion at the base of the slope, like we've seen on some of the cliffs earlier already, loading of the slopes. If somebody, for example, builds something very heavy like a swimming pool at the top of a slope, sometimes that can cause a landslide to happen. Earthquakes, of course, and also man-made, human-made interventions like cutting a slope too steep or building an embankment that is too steep or can't withstand the rainfall or the water regime within it. I'm going to give you a little overview of UK landslides now. So the UK, we don't suffer from monsoons or major earthquakes, but we are a very densely populated country and we've got an ageing infrastructure of roads and railways. Luckily for us, we've got a very limited number of fatalities, but we have also got many landslides that are post-glacial. So at the end of the last glaciation, and there's quite a lot of water around. In fact, like this landslide behind me, that's when a lot of the bigger landslides that we see inland that still exist occurred. But UK generally, you don't really think of it as a place for landslides. However, our national landslide database as of this month, yesterday actually, is 18,219 that we've got records of. So not all of these are live moving landslides. Some of these are relic ones, like the ones at the end of the last glaciation, for example. But this map here, which you'll see a little bit more in this talk, what it does show you is that the coastline is very active, and especially along here, along the Jurassic Coast and other sections, particularly along basically the east and the southern coasts in particular. And many more of the inland landslides especially, or and at the coast, but many of the ones that we thought weren't moving, we've since found actually are active. There's a new-ish initiative called the European Ground Motion Service. I've included the link here and you can look that up for yourselves. And what that does is it uses satellite data that show incremental vertical change. And what we've been able to see is that some of the areas that we thought weren't moving are in fact moving, moving downwards at a regular rate per year. The UK is underlain by quite a range of geology, and overlaying all of this to around kind of this area here, sort of mid-country, are the glacial deposits from the last glaciation, so which are kind of softer and more prone to landsliding. We've got a period of an area of steep slopes that run down from Scotland and into Wales and parts of the southwest, and the landslide distribution kind of reflects that quite nicely. So back to our landslide types. So I'm going to give you an example or two of each of these types. So the first type is falls and topples. So a rock fall is essentially a rock that just falls vertically straight down, and then this then breaks up and rumbles down the slope. And then a topple is where it pivots around a point, and you tend to get talus cones more with those. So these two examples here are, this is from Pennington Point, on no relation to me, but this was caught on camera actually at a time before people had mobile phone cameras everywhere. So this was a particularly unusual shot. And then these are slower moving topples that are on the Isle of Purbeck. I don't mean that, I mean the Isle of Portland. Burton Bradstock, which is some of the cliffs that Sam has already showed. I mentioned about someone losing their life. So sadly, back in 2012, there was a series of 2 rockfalls that happened about 20 minutes apart. And tragically, 22-year-old Charlotte Blackman was killed here. The rockfall was 30 metres long, 20 metres wide, and it ran 10 metres high, and it ran out right over the gravel beach into the sea. What caused this landslide to happen? Well, there's obviously here coastal erosion and weathering. There was a period of wet weather around this time. Also, there's the question mark around the thermal influence of in the heat waves, for example, where you have periods of temperature difference where you've got heating and then rapid cooling of these rocks, and they're already full of fractures. So there's vertical joint sets and fractures in here, but they also run parallel to the shore. And this is taken not long ago, last year, up in the cliff tops, where we found all these cracks up in the grass at the top. So the next one is flows. So flows can be slow, but they can also be very rapid, and they tend to happen in saturated materials, and they leave this sort of distinctive upside down funnel shape where the material has stopped moving. What can happen is that an initial bit of material detaches in the slope, and then it finds a channel, a pre-existing stream, for example, and then rumbles down that, picking up more and more material as it goes. This is a common feature in some of the roads in Scotland. So the Rest and Be Thankful Pass, which is just sort of north of Glasgow, on the A83 is a repeated site of debris flows. They've got all sorts of measures to try and help slow this down, but also to monitor the slope. And this is where we had a detachment again, and then debris flows. And the impacts of this is that there's actually a 57-mile detour here. So if you're a logistics company, or you are about to have a baby, you need to get to hospital, and the hospital's on the other side of where you live, then that's actually quite a big deal. And this is the deposit on the road close up from one of the events. And whilst it doesn't look absolutely massive, if you were to hit that at speed, because this is a 60-mile-an-hour road, that would be quite a disaster. And then Aberfan, which is probably the saddest of all UK landslides. So in 1966, the worst mining-related disaster in British history sadly took place. In 1916, the local colliery ran out of tipping space in the valley floor, so places to put the spoil heaps. So they constructed 7 big conical tips, and you can see some of these back up in the top of this picture here. And these was all surrounding the Aberfan village, and these contain 2.1 million cubic metres of colliery spoil. And then around 9 o'clock in the morning, or just shortly afterwards, tip number 7 collapsed with an absolute deafening roar, and it avalanched straight into the village. It thundered down the hillside, ploughing into the farmhouse and the cottages that lay directly in its path, killing everyone within. And 107,000 cubic metres of black slurry then hit the disused canal, fractured the water main, and leapt across the railway embankment. And once in the village, the landslide destroyed 18 houses, Pantglas Junior School, and part of the neighbouring county secondary school, before finally coming to rest on the Aberfan Road at 9:15. In total, 144 lives were lost, 116 of which were children, mostly aged between 7 and 10, who died in their classrooms on the last day before half term, which is just heartbreaking. So since then, industry and legislation and engineering geology as a science have really moved forward to make sure this is never repeated. In actual fact, engineering geology as a science began at BGS in response to this event. So moving on to rotational landslides. So Sam quite nicely described this earlier. It's where you get this circular plane of movement. And I often use the analogy of if you had a hot spoon and you put it into ice cream, you took it out again, that kind of spoon shape is what can often be that slip plane surface. So this is from 2013, where again it's colliery spoil, but the weight of that loading the slope and the water within it meant that it actually pushed the railway up, causing millions of pounds worth of damage. Another example of a rotational landslide is the Holbeck Hall Hotel landslide that happened in 1993. So this was a rotational landslide that then degraded into a flow across the beach. It destroyed the 4-star Holbeck Hall Hotel 2 days after it begun. Amazingly, no one was hurt, despite the alleged reluctance of guests to leave. Even when there was a gaping chasm 10 metres from the hotel, people still didn't want to leave. 1 million tonnes of glacial till flowed across the beach, forming a promontory about 200 metres wide, projecting about 135 metres from the foot of the cliff. And I've read that. And this, there's some pictures of the hotel. So you can see the kind of the damage that was caused there and how it was literally chopped in half. And we've also got lots of other photographs of this, and there's a grand piano still inside from some of these photographs, which just makes it seem very strange. This really caught the attention of the national media, and this site is used to demonstrate landslide processes and how you can remediate them. And this is what it looks like today. The Holbeck Hall Hotel was up here, and I remember being taken on a trip at university to go and see it as an example. So translational landslides, they're sort of similar to rotational landslides, except rather than having that spoon-shaped rotation, it's a direct slip down the slope on a planar surface. This is an example from up in Scotland. I'm not going to attempt to pronounce it because I won't get it right, but this was a translational slide that then degraded into a debris flow, and it hit it derailed a goods train on the Crane Larrick to Fort William line, and the engine was actually completely derailed and fell down the embankment towards the lock. And this happened in very shallow deposits on that slope. And then a complex landslide is simply 2 or more landslide types happening at the same time. So this is Stone Barrow, I think, in Dorset. And you've got the rotational landslide here, you've got flows here, and you've also got some falls and topples in the back scar area. And then this is my favourite landslide. This is up in the North York Moors, and this is an absolutely enormous landslide here. And we know that this happened at the end of the last glaciation. We've dated some of the sediments here to 2070 years before present, so that's when we think it was last active. And this is multiple blocks that have moved down this slope that then degrade into flows, which you can see reflected in this sort of lumpy, bumpy surface down here. Now, we know that this is currently a dormant landslide. However, with rainfall increasing and intensive storms increasing with climate change, this is the kind of slope that we need to keep our eyes on because it could well reactivate. Now I'm going to give you a little bit of an insight into some of the research that we do at BGS to do with landslides. So we've been collecting information on landslides since mapping began in 1835. As you can see, technology's changed quite a lot, and so has our outfits. No one's wearing fancy shorts and no socks like this anymore, and the accommodation has also improved a little bit. We've got these computers that allow us to use GIS technology, which is a little bit like using Google Earth to be able to map polygons where we can see landslides happening. We're using lots of new other equipment, and even women are allowed out now, which is, you know, quite nice. We've got some observatories, so starting kind of at the local scale, we've got a few observatories around the country. So one of them is on the East Riding of Yorkshire coast up in Aldborough, and here we've got lots of different technologies looking at how these slopes are changing over time. So we've got pairs of boreholes in the ground behind here that have got information about what is happening with the groundwater inside, and how the movement of the cliff is changing over time as the land sort of relaxes with stress relief as the material is moved from the front of it. And we've been using lots of different technologies here as well. So we've got LiDAR. This is quite an old LiDAR picture now. We've got other LiDAR, which is in a rucksack that we can walk around with. And then we've got LiDARs on drones, which means it's a much safer way of collecting data. And a LiDAR is essentially, it's a laser scanner, which makes it sound quite scary, but it isn't. And it's quite safe to use. And it's essentially, it's like shining a torch at the cliffs, and it sends a laser beams, millions of laser beams out, and then they return back to the device, and you can get this three-dimensional surface. We go to carry out these scans 4 times a year here, and what we can do is we can compare the scans against each other to get these change models, which means we can calculate the amount of volume of material that's been lost, which is quite useful to know, because that's a volume of material that's being put into the coastal system. Another observatory we've got is up in a field in Yorkshire again, but this is a completely different type of landslide, not at the coast. And here we've really tested a lot of geophysics to look at moisture within the cliff, and then how that behaves according to the slope as it moves. We've got at the moment as well a prototype flume within our landslide lab, and this is where we're simulating debris flow type landslides. This is our prototype, so we will be getting one that's building one that's considerably bigger than this. I think this one's 4.5 meters long at the moment, so we're hoping to upgrade soon. So talking about material that's coming into the cliffs, one of the things that I've been working on over the last few years with Lancaster University is looking at the interaction of the beach itself with the landslide process that we're seeing and being able to measure in the cliffs. And one of the features that happens in the beach that along this section of coast is this feature here. This is locally known as an ord, O-R-D, and this is where the beach has a particular formation that then exposes the platform underneath the beach, and so you're getting deeper water, which means that there's more energy in the sea as it's hitting those cliffs. So you get this steepening of the cliffs, and these slowly migrate southwards as like a great conveyor belt as it's moving along. And you can see in the cliffs where one of these ords has moved past and ripped out some of the material along here. So we've got a paper that's currently in press that's looking at this. Another project that we've had an observatory scale is to do with the Internet of Things. So if you haven't heard of the Internet of Things before, it's essentially, what can I compare it to? Like, the hive in your home. So some people have got you can control your heating through this hive thing on your mobile phone. Some people, their dishwasher will tell them that it's finished washing the dishes on their mobile phone, and same with washing machines now. And what that essentially is a sensor that is receiving information and then taking an action to text you to tell you the dishwasher's done by itself. And we are using that principle to look at building affordable and ultra low power sensors to monitor landslides. And we did a project called the 5G Rural Dorset project, which still has a website up, and that finished last year, where we tested some of these sensors. And this was with Bournemouth University and Dorset Council in particular, and also Vodafone and others. And essentially some of the sensors were trying to detect movement, widening of cracks, and then moving forwards, we're going to be looking at rock temperature, around that question of thermal change. There'll be something that we're going to be building around going down boreholes, what the weather's doing, and also potentially beach thickness. So the lessons that we learned as part of the 5G Rural Dorset project, which is actually at Burton, but we're looking now at West Bay and also at Lyme Regis, is now being used as a demonstrator within a Horizon 2020 project funded by the European Commission called the HUT. And there's other places in Europe that have done similar kind of work. So we're all learning from each other to try understand better how to do this, because it's completely new. It's quite a challenge for lots of different reasons. Things like network connectivity, batteries, how does a sensor, how does the housing around the sensor withstand coastal environments, which are very harsh. So our friend here, the National Landslide Database, I won't talk too much about this, but this is essentially one of the most important pieces of data that we have at BGS for landslides for the UK. So this underpins most of our nationally important landslide projects, and it's used by a range of people, and it's absolutely fantastic for, has there been a landslide in this area, or if the government comes to us and says how many landslides have happened this summer, we can tell them quantitatively. And this is updated on a daily basis, and information comes from a very wide range of sources. So that might be from BGS landslide maps, or it might be from reports or newspaper cuttings, but more recently it's been social media. So the power of social media has been quite astonishing, actually. So in 2012 we started using Twitter, or X as it's now called, to gather information on landslides, and the amount of information coming in was absolutely astonishing from what we saw before. And the kinds of information you can get from this, because over this 10-year period, everybody's gone from having a phone to text and talk to their friends, to having very good quality cameras, and a culture of uploading that information to the internet. So we can get information about landslides that have just happened, from people as well who are scientists that we know as well. So we know, we trust the information that they'll send. We get information about diversion. So this is that 57-mile diversion that I mentioned earlier around that Rest and Be Thankful pass up in Scotland. I think we've already seen a similar image from the Jurassic Coast Trust here of the Seatown landslide a few months ago. But we also get information about what causes landslides, such as this one, which is obviously the sea hitting the cliffs here. And this graph just quickly shows you that this is time along the bottom, and then this is the number of landslides that we've been recording. And leading up to the point we introduced Twitter, we've got an awful lot more landslides coming in. This also gives a slightly false impression that there are less landslides happening over time. And what this actually reflects is some very wet winters, and also some quite low news times, I think, in the UK. So this period, this peak here in particular, there wasn't much happening, I don't think, over that time. And the more landslides were reported, the more landslides were reported. So the more reporting, it just kept this hyperbole going, and we saw quite a bias towards it. So that was quite interesting in itself. So building on this, we've worked with computer scientists in Qatar who do a lot of work for the humanitarian sector, and earthquake and social media scientists in France to build this global landslide detector tool. And what that does is it automatically scans Twitter for mentions of landslides, so keywords of landslides in 32 different languages, which we will be expanding. So they have to have a keyword and a photograph, and then we've used a machine learning tool to be able to say, is it a landslide or not? So this diagram here at the bottom shows you that the data come in, they're all collected, and then the tool decides, is it a landslide or is it not a landslide? And then all those that are landslides, it presents here on this tool, and then places those, locates those on the global map. And this was all going quite well until Elon Musk bought Twitter, and now things are a little bit harder because he's changed a lot of the rules, but we're persevering. As well as using social media, we now have the added advantage of satellite imagery, and some of our colleagues at BGS, we've got a whole department that are experts in this. And this is the landslide tracker tool that's been led by Dr. Alessandro Novellino at BGS. And this automatically detects and maps landslides from satellite imagery. And this is particularly useful in areas where you've got something like an earthquake or a monsoon that has caused lots of landslides to happen at the same time. And the data need to be gathered very quickly and given to the people that are trying to respond to that event. Back into the UK again. So we've built lots of different maps and models based on our data and our expertise and knowledge of the different geology. So here's our friend, the National Landslide Database again, and using that in combination with geology and other preconditioning factors, we've built 2 different landslide susceptibility models for different landslide types. So this is for the debris flow type landslide, those ones that rumble down the slope when there's lots of water around. They have to be steep slopes. So not surprisingly, these happen in Scotland, parts of the Lake District and North Wales. And then these, this diagram here on the top right is for shallow translational and rotational landslides. We've also divided the country up into landslide domains. So this is where we've said, okay, well, in this area, we expect these types of landslides to happen. And then we can then drill down into subdomains so that we can get a really good idea of the kinds of landslides and the combinations of landslides that we would expect to see. We've also started to look at exposure. So this is the kind of the likelihood of somebody going along a road being impacted by a landslide. So we've started to do this up in parts of Scotland along the road network. And this looks at the damage of the road, and it will link with other information such as the weather. And then moving forward with climate change, we've got 2 projects at the moment that, as well, many projects, but one that I want to talk about today concerning landslides around climate change. The first one is called the Chamfer project. So this is a multi-centre project. So it's led by the National Oceanographic Centre with the UK Centre for Ecology and Hydrology and also ourselves, BGS. And we're looking at characterising the coast with respect to flooding and coastal erosion in terms of climate change and sea level rise. So here, newly, we are considering not just the cliffs, not just the beach and the sediment, not just what's happening offshore, not just what is happening in the hills behind, it's about, or in the rivers, it's about all of those systems and how they all work and interact together. And also included in this is the human element, which has arguably quite a large impact on what's happening with all of these processes. And we're creating a national scale map where we're looking at developing the different types of coasts and how different nature-based solutions might be used to help manage that coastal adaptation that needs to be gone through. So we're looking at things like seagrass and oyster beds and kelp, and to see how they impact on the energy of the waves. Another project is the Terra Firma project, which also includes landslides, but not just at the coast. So this is looking at the average global temperature, makes an assumption that it will reach 2 degrees above the current target, and that humans will manage to get to net zero in time. And so it's about going over that 2 degree overshoot and then coming back down again. And what we're trying to understand with lots of different partners is how will the landscape will respond to that, and what are the processes that might be irreversible on a global scale. This is as well. We're also in the game of forecasting, so we work closely with the, or are in fact a partner of the Natural Hazards Partnership. So this was established in 2011 following a government review after the flooding in 2007. It's made up of 19 public bodies. So these are different government departments, public sector research institutes like BGS, and agencies like the Environment Agency. And this is used for scientific information, research and analysis on natural hazards. And it's for the civil contingencies, the responding community. It's about situational awareness for local councils, for example, and people like the Coast Guard. As BGS, we provide advice on landslides on a daily basis. And it's like a 24-hour forward look as to what we think is likely to happen on a according to the weather and our expertise. On a regional scale. And we also do this, not the landslides team, others at the BGS, or for earthquakes, tsunamis and space weather. We are a member of the International Disasters Charter. So this is where an event like the one I mentioned earlier, where you've got something quite major that's happened. And this is an example from February, like the Turkey-Syria earthquake. And the Disasters Charter takes data from satellites that wouldn't ordinarily be available to everybody, so like commercial satellite data, for example, and then it gives those to the different members, and sometimes with the question like, are there any landslides that have happened within this area? And we will, on a quick turnaround, map where those landslides are and get them back to them and to the people that need them on the ground. So this is my last slide. I've got overrun a little bit, but just wanted to talk a bit about some of the future work that we're looking at. So we're looking at combining a lot of the pre-existing tools, especially for real-time data that will allow us to get a really good idea of what's happening where and when, and potentially why as well. We're looking at being able to record damage and loss, because this is not done very well at the moment. We're looking at working with other organisations on a global scale, and also about how climate change is going to impact landslide processes and other hazards moving forwards. And that is the end of my talk. So I will stop sharing and give you back to Sam. Can I remember how to do that?
Thank you, Kat. Right, don't mute yourself, because we'll come up with some questions in a minute. That was really interesting, and it just gives hopefully everybody the sense of how much work is involved behind the scenes in trying to understand landslides and sort of get to grips with them and make decisions around what to do about it. And I should say, the Jurassic Coast Trust do not lead on any of that work. Although, you know, the Jurassic Coast has this brand, this name, which is very high profile. Of course, it's the landowners and it's the local authority, the risk management authorities, their employees, their staff, the coastal rangers. They're the people who are going out most of the time doing the legwork to manage these issues, closing the paths, making decisions around those kinds of responses. Of course, people like the BGS are doing their amazing research, and Kath is on hand to advise. We're on hand to provide. A lot of the time, from our point of view, and from the council's point of view, we're helping with the communications around these issues to help people to understand them. But we're not on the sort of coalface dealing with them, if you know what I mean. I should have said at the top of the talk as well, apologies to everybody, but it's International Geodiversity Day today, which is the whole reason we're doing the talk on a Friday night. Ordinarily we may pick a different evening, but yes, it's a day. It's only the second year that we've had an International Geodiversity Day, and it's celebrating all the ways in which geodiversity connects to society and is worthy of celebration. So that's great. 6th of October every year. So something else, Kath, from your slides, it was really interesting. The dormant landslide at Mark Nab in North York reminded me of all of the valleys, the glacial valleys that we have in Dorset. There you go, it's in the background. And particularly for me, Abbotsbury Hill. So if anybody's driven up Abbotsbury Hill, next time you do it, take a close look at the immediate landscape on either side of the road, and you will see something that looks very much like the photograph behind Kathy there. And it's because that is also a dormant landslide system. And one of the reasons it's still dormant is because Chesil Beach sits in front of the toe, and the sea hasn't been able to nibble away at the foot of the cliff at all and destabilize that thing. But as Kat explained, you know, with climate change and more rain, and you know, as Chesil Beach evolves, we may see at some future time that whole slope of Abbotsbury Hill destabilize, and perhaps that road will no longer be sustainable. But hopefully that's a long way off. Now, I know we've overrun. Thanks for sticking with us so far. We have lost quite a few, so I'm going to try and wrap up as quickly as possible. We did have 3 questions, which I'll try to give some very brief responses to before we depart. So if I share my screen once more, we'll get those up so that people can read them as well. So there's no answer to this text. This is how the questions came. So which areas of the Jurassic Coast do you see as being most affected by sea level rise in terms of rate of coastal erosion? And there's a question there about the beach level around West Bay anecdotally has disappeared over the last 10-15 years. I mean, yes, I live near Bridport, so anecdotally I can confirm that. It seems to be permanently lowered now by quite a large degree. And the effect of that, of course, is to expose the lower parts of the cliffs to more waves, because it will be more conditions of the sea, more normal conditions of the sea, if you like, that will be able to send waves riding out the beach and into the base of the cliff. Rather than just the big storms doing that, it'll be all states of the tide. And so that will undercut the cliffs more and potentially cause more rock falls. In terms of the first part of that question, I don't know, Kath, if you have anything to offer on that, but it's quite hard to predict because it depends on wave climate. It depends on the state of the beaches, because the beaches sort of come and go. Sometimes their material gets pulled away and then it rebuilds itself. And beaches are fantastic natural coastal defense systems. So if you've got a great big healthy beach in front of the cliff, that can help. But then, of course, you've got the rain as well. So rain affects it a great deal. So that would be, that's quite hard for me to say in terms of rising sea levels. What do you think, Kath? Anything to add in on that?
Yeah, I mean, I can't really comment on specific places because that's not within the work that we do at BGS. We're not involved with that kind of coastal management element of the Jurassic Coast. However, the impacts of sea level rise, which I think is the main part of that question, it's about looking at what those impacts are. So it's going to be things like flooding of lowland areas. So looking at what actually is behind the beach. So if you've got a cliff, then that's land that will erode. If it's low areas, then you're going to be looking more at flooding moving forwards. And one of the things that also needs to be taken into account is with sea level rise isn't actually just that localized area. It's a much wider area in terms of both sort of spatially, but also over time, and looking at longer term trends. And it's all wrapped up with that sediment dynamic. And some of the research that we've done at BGS proves the link between coastal recession and what's called the beach wedge. So that material that sits on the beach. And yeah, there's a lot of questions around that, sort of uncertainty around that. So yeah, rates of coastal erosion are definitely going to be exacerbated moving forwards.
Yeah, quite right. Okay, so the next question was risk management on the Jurassic Coast and the balancing act, keeping people safe versus enjoying the coast open for everyone to enjoy. So, I mean, I touched on that in the slides that I had up. It is very difficult to pitch the messaging in the correct way to make people aware of the hazards, but to not scare them off entirely and stop them coming here at all. Because, of course, we do want people to come and enjoy the Jurassic Coast and have a good time. We want to do it safely. There's a specific question there about East Beach and closing the beach off to the public. Now, this isn't something I can easily answer or give you definite answers about, but I know that when the landslide and rockfall protocol was being created, there was a lot of discussion with the emergency responders about this and with the council about whether it's even possible to close beaches because they are open access areas. And the way things operate at the moment, it is only possible to close a beach during an emergency situation. So if an emergency is declared, the police they have the powers to close the beach. That's often happens only when there is risk to life, or we think somebody might be trapped under a rockfall and a rescue is required. But once the emergency situation is finished or is over, then the expectation is that the beach can be opened up to the public again, because there's no sort of powers to close it, if you like. The coast paths are slightly different because, of course, they are rights of way, and that is managed by the council. They can be closed, and there is no right to access them if they have been closed. Normally, they will be rerouted, hopefully, to be able to open them up again once the judgment has been made that's appropriate to do so. So the beach is separate to the coast path, and in terms of letting people on the beach, there's little control, but the coast path, there's more control, essentially. And I'll skip on to the last one. So we still may be a way off yet. So it's a sea level rise again. Do you think a major flood event could be the tipping point to residents and businesses starting to move away from coastal areas due to a fear of property prices collapsing? So this is really interesting. It's a really big question. And I think if we were thinking very particularly about the communities that are right on the coast, I think the better question would be, are they sustainable? So it is likely that there will be one significant event or perhaps a clustering of storm events that happen in very close succession that will cause irrevocable change. So coastal communities will be forced to adapt. In the long term, if sea levels rise and the coast or the cliffs behind don't retreat quickly enough, beaches may be squeezed out altogether. So beaches may disappear. Again, that's a question of adaptation rather than necessarily communities becoming unsustainable. But if you think about the landscape in Dorset, of course, take the town of Bridport where I live, that doesn't have a beach, but it's a thriving community and a very popular with holidaymakers. So just if we don't have beaches, that doesn't mean that people won't want to continue to live here and work here and visit here. There are plenty of reasons to come to Dorset and East Devon without the beaches or being able to access the coast easily. And relating it to climate change, well, in a sense, we are vulnerable in the same ways as habitats and wildlife. So what's often said about climate change in general is it's not so much the change itself, it's the rate of change. Because the rate of change means that things aren't able to adapt quickly enough. And human society is the same, really. So the change from sea level rise, if you like, is perhaps inevitable, but